Okay, okay. So now we're back. The third round of seeding is over, and now we're gonna switch to another round of lightning talks. Next up, we've got Jason Norman. He's from Fetch Robotics, and Fetch Robotics is a manufacturer of software and hardware in the robotics space. And he's gonna tell us a little bit about Fetch Robotics, and he's gonna give us an overview of the company. So now to you, Jason.
Yeah, thank you. Thank you. And hi, everybody. Thanks for having me today. Looking forward to taking you through a little bit of the transition in warehouse automation from manual processes to robotic solutions as we transition across to sort of new age technologies, fronting menial tasks for workers and how we produce and capitalize on everything inside that industry currently. So if I take you through a little bit of history around Zebra as a company, as well as Fetch Robotics. Zebra historically is a manufacturer of barcode scanning solutions, print devices, and wearable technology. So if you think of us around automating manual processes and equipping manual workers with technologies to increase their throughput and productivity on their daily working basis. And alongside Fetch now, which Zebra has now acquired over the past 6 months, we're now looking at augmenting that manual workflow alongside the new age technology, which is automated mobile robotics, right? So if you think about the processes of humans working with robots and how this transitions into the future, hopefully we can give you a little bit of an insight to how that may look next year, 2 years, 3 years, 5 years time as we progress. So what we see from an industry basis is around 80% of organizations plan to invest in new technologies over the next 5 years. And really they're looking at issues around their own facilities. They may focus against, okay, what's our throughput on a daily basis? And when I say throughput, I mean, how can we automate our picking? How can we increase the online sales drive to e-commerce following the pandemic? How can we really maximize technology to improve our facilities and capture a return on investment, but overall gain us more productivity as we're progressing through and transition into this sort of new age of view against robotics and manual workers working together. So some of the use cases and points that the industry is extremely strained against at the minute is around labor intensity. When I say labor intensity, I mean staffing issues, right? If we think about a warehouse and we think about particular companies such as Amazon, they have a really high throughput of staffing, meaning the other providers and other transition companies are slightly struggling to find the headcount of correct people to come in and work these facilities and increase and continue that productivity to each site that they're working from in their distribution centers. They have a high turnover of staff that focus on coming, being trained, either not enjoying the job, being offered more money somewhere else, and leaving that facility over a course of a 2-week period. And that is an extremely high cost for the companies that are hiring these people, because they have a cost against training people, they have a cost against onboarding them as a brand new hire, and essentially robotics is the answer to that solution. A robot can work around the clock for 9 hours a day. He's not going to complain to you as he's coming down the aisles about the amount of workload that you're giving at him to any sort of during period of the day. And overall, we're also just sort of covering those menial tasks to allocate the pre-existing workers to other tasks that may mean a little bit more in terms of the entire process of everything that's going on. So we're focusing on staff retention, labor issues. How do we address that with new automation coming into the world? So if I show you a little bit on our product roadmap, as was mentioned earlier, Fetch Robotics is a software and hardware manufacturer. So I'll just take you through our family of robotics at the minute, starting from the left-hand side and some of the use cases that run alongside this. We have our roller top solution. So if you picture a large distribution center or warehouse or fulfillment center, they're filled with conveyor belts. That's the process that traditionally people have used to try and save somebody walking your box of goods from one end of the warehouse to another. They traditionally place it on a conveyor belt and move it across from there. Now with Fetch and the roller top solution, from in an aisle where you've picked the product, you place that tote on top of the robot and it would drive directly to the conveyor belt to then unload that tote. Or if you think about it in the reverse fixture, it can go to the conveyor belt, pick the tote or the box up and then move it back across to the rear fulfillment area essentially. And how we do that is via motion sensors. So we would fix a motion sensor to the end of the conveyor belt. as soon as the robot enters that facility and it's recognized as the correct robot, we can then start the conveyor belts in motion and the rollers to then move that box on top of the robot as it moves away. The one in the middle here, the HMI shelf, is used for picking operations. So you can see a small integrated tablet there. So we can display order references via that tablet to the worker, so they know the exact product they're looking to pick, and place it on the robot and use the tablet to send it to its correct location. We have different capabilities in terms of the weights that we can carry. So with this product here, we can carry around 78 kilograms of product at any given time, much more than your sort of traditional manual worker who would be carrying a lot less, or you'd like to think so anyway. And then to the one in the middle, the Cart Connect 100, which carries around 100 kilograms of product and is a very similar sort of use case where you would have the cart at the end of a picking aisle. The person is loading the goods onto that cart and then maybe using a barcode scanner to scan the location of the cart to trigger the robot to come and pick the cart up and move it to the dispatch area, then leaving the worker to stay in that aisle and pick productively as much as they possibly can, with the robots coming to and from that allocated area. The tag surveyor in the middle is an RFID inventory checking robot. So with RFID and ultra high frequency RFID, we can tag individual items, send the robot down the aisle, and it will give you a full picture autonomously of every single piece of inventory that you've got sat in that particular aisle and feed it back via our software application, which I'll show you shortly. The two to the end are slightly bigger robots, or pallet moving robots, as we would call them. And the trick is in the name again. So the Cart Connect 500 can carry around 500 kilograms of payload capacity of product. And the one to the end can carry 1,500 kilograms worth of product. So you might see this in manufacturing facilities, particularly car manufacturing facilities where the goods are slightly heavier, bigger and bulkier. And again, we're automating that process with large-scale robotic picking arms that pick and place the product on top of our pick and drop stations. The robots use their lift mechanism to pick up the whole station and move the solution forward, essentially. And again, point-to-point execution, we're covering that walking distance that would have traditionally been done by a forklift driver or a manual worker just carrying single line item boxes from one area to another. If we move to some further solutions we have, and again, I won't spend too much time because it's very similar on use cases. We have the capability to carry multiple totes or boxes at any given time. We have a put to light capability, which is this LED strip down the side. So it allows via our software to not only allocate which pick is coming from the tablet, but light each individual area so the worker has a visual representation of where that product they're picking should be loaded and at what capacity at the same time. We have Bluetooth capabilities and we have NFC capabilities again for the workers to be able to log themselves into the robots and work manually alongside those at any given time. So again, that just imagine that process, but imagine a robot being allocated into that to one individual worker that's then just pushing through the throughput of product to the maximum capacity at any sort of given time. So there's a few different variations that we can offer into the market with no tablet integrated, one tablet for a worker to work alongside, or two tablets. So then you have multiple batch reference pick orders that are coming through and visual representation of each individual product to then be loaded into the tote. And the one at the end here essentially again is a conveyor belt use case. So there's a lift mechanism here that allows us to orientate the rollers at any sort of height of any sort of conveyor belt, again in the warehouse with the option of an integrated tablet. So everything that we do works via cloud-based APIs. So again, we're not on an on-premise solution inside each facility that we work with. And we set the workflows and we set how the robots work via Blockly. So what we try and do is train warehouse managers to actually be able to integrate and code this software themselves. So they drag a position of a warehouse into the software API. They then have a drop-down option to allocate which robot will be set to that zone and for how long at any given period of time as well. So we try and keep the simplicity moving and as agile as possible with the robots. So even individual workers such as warehouse managers can grasp this and run this on a day-to-day basis. How it works is we come to a facility first of all, and we drive a robot around manually with an Xbox controller. So we just plug an Xbox controller via USB into the robot. We drive it around the entire facility via LiDAR cameras, upwards and downwards facing LiDAR cameras. We then have a augmented virtual reality version of the map. So you can see the movements in here. This is from a facility that we did fairly recently. And the circle yellow zones that you see are the picking areas that the robots are allowed to go into. The red zone areas are where the robots may not be able to go because there may be high traffic with forklift drivers or manual workers coming through there, and we want them consistently moving. So again, we're calculating a return on investment for our customers. Then overall, I keep saying it, increasing the productivity of each individual site. So there's different ways via safety that we work, and this is probably the biggest question that we get inside the industry. So essentially the robot is set with LiDAR, machine vision, as well as an upwards and downwards facing camera. We don't need QR codes on the ground to guide the robot. It's completely autonomous. Once it has a view of the racking inside a warehouse or any individual facility, it can then augment its own way and in real-time live location updates, update any other robot that's also inside that facility at the same time. We also have an integrated LED light to gain the attention of the pickers that may be concentrated on other works, because again, we don't want the robots sat idle. We want them positioning themselves and moving as quickly as possible. So this video will show you a little bit of an augmentation. Somebody's left a pallet truck and a pump truck in the middle of the aisle. The robot recognizes this, transitions and finds a new route as it's coming through, and then we'll let every other robot on site know that there's something in the way down that aisle. You can still progress a way through, and you can still transition and do the daily tasks that we're looking to complete. Aside from that, we get a lot of questions around people stepping in front of the robots. Again, they will just grind to a complete halt, give themselves between 5 to 10 seconds to augment the area, then transition and move forward again. So in terms of safety certifications and safety features, we have the highest grade on the market against the robot consultancy appreciation completion survey that we've done fairly recently. So again, the reason we can carry the highest payload capacities, have the LiDAR vision, is because we have those safety certification features that are already embedded inside the robot. So I'll just end the presentation there with a little video, which will show you guys some of the use cases that I've just spoken through a little bit. Okay. So I'd just like to thank you guys for the time today, obviously, and open up to any questions that you may have inside the chat box as well.
Thank you very much for the excellent presentation. You've talked earlier about the picking robot, and that there's still a human in the process of the picking robot. Now, the question for me is, where's the limit between or where is a human still required in the process, and why can't we go fully autonomous?
Yeah, and it's a good question, and I think every process still has a manual operation level to it, right? And particularly with the robots, we don't have the capability to pick physical items from a shelving unit, right? So you still need the throughput of somebody to physically lift and load the robots. The thought process is really around keeping that person inside 4 aisles inside a warehouse. So their picking productivity is maximized because they don't have to walk those lit single line items to a conveyor belt or to a dispatch area. The robot covers that, and that's where you gain your real return on investment. Okay.
So would I be correct if I say you're actually assisting the human and not replacing the human in the
Yeah,
warehouse?
that's right.
Okay.
So the way we describe this in the industry is a goods to person robot solution. So we are just carrying and facilitating each individual picker's working day, essentially.
What is your most used robot? What is most bought from you?
Yeah, so I would say it would be our HMI shelf, the picking integrated with the tablet, or our new product, the Flex Shelf solution. So we've seen a lot of individual use cases where companies are driving to online sales and e-commerce now, particularly following the pandemic. Traditional retail, where you're in the store, isn't transitioning the same way as it used to. We're very much driven to online sales, which means larger distribution centers, larger warehouses, and a larger need to push as much product as you can on a day-to-day basis.
Obviously, there's a lot of R&D and a lot of development involved in developing such robots. How much of your budget is R&D and how much is other stuff?
Yeah, so I would say we're putting at least 10% of our global sales back into R&D
Mhm.
processes. And when I say 10%, if we think about the larger Zebra with the barcode scanners and printers, we're a $4.4 billion USD company. So around 2% back into that is a lot of R&D and engineering, right?
Yes, yes, yes. And you've said that you're offering a cloud solution.
Yes.
Now, for me, the question is, where does the processing happen? Is it a mixed solution between cloud and offline, or is it all done on the robots themselves?
Yeah, so the robots are augmenting that themselves and then
Mhm.
transitioning it via the network infrastructure that's on site. So again, we're just pushing up to AWS services via our
Mhm.
cloud APIs via port 80 or port 90. So we transition and we have cloud-based servers for the United States markets, and then we also have an individual one for Europe in Paris due to GDPR regulations
Mhm.
and data protection. Yeah.
Okay, yeah, and this is kind of also the next question about cloud security. Obviously, this is a big topic right now. Is it also possible to have this on premise in your warehouse, for example?
Yeah, so that's actually on our long-term roadmap. You'd
Mhm.
be surprised at the amount of questions we get similar to that from customers that want to run this on premise on their own servers. We don't currently offer that, but certainly it would be something we do for the future.
So you also said earlier that you're driving through the warehouse manually in the beginning using an Xbox controller.
That's right.
Are you doing SLAM in the end, or are you doing just localization when you actually deploy the product?
Yeah, it's just localization as it
Okay.
stands. There's no SLAM entity come into that. Essentially, we do it once with one robot.
Mhm.
So anything following that has that orientation of the map
Mhm.
via the cloud APIs.
And if I need to update the map, for example, if something changes in my warehouse, then I need to rescan the whole environment.
Well, because the robots are driving autonomously, if
Mhm.
somebody leaves a pallet in the way, it will augment a route around that and update the map real time. But if you're completely restructuring your warehouse and changing the racking, yeah, you'd need to drive it around again.
Yeah,
Yeah.
obviously, yeah. And you've opted obviously for a lighter solution here. Why not for something, for example, markers on the floor or markers on the ceiling?
Yeah, so it's around the transition of change and cost association that comes with that to each individual facility. If you think about laying QR codes on the ground or laying tracking systems for a AGV robot to move, you're limited in terms of the capability of what it can do. With ours, because they're free flowing and free moving, any change or adaptation that comes during the day, you're covered for because the robot will see that itself and then update anything else that needs to be required, right?
Okay, thank you very much. I mean, for me, that's it from me. And
Okay.
there's no other questions from the chat so far. So I'd like to thank you very much for your presentation. I found it very interesting, and some people in the chat as well.
Great.
And
Thank
I
you.
wish you a very good weekend.
Yeah.
And now
Thank
back over to the experts here in our robotics lab.